All right, welcome back to Lag Demon Programming. Today we're going to talk about state machines and their importance in programming and how to use the state pattern to implement them in an object-oriented style. So first of all, let me show you a little presentation about state machines in general, and then we'll get into writing some code.
All right, in this video we're going to talk about state machines, but first I always like to tell a little joke just to get the audience warmed up. You know how it is. They say that's what you're supposed to do, so how many engineers does it take to screw in a light bulb? Well, probably about 15 and 3 years. So, I'll give you a second to stop laughing. I know. But what is a state machine anyway? Well, they're called finite state automaton, or finite state automata, if you want to say it plural. It's a mathematical model of computation. And there's a fair amount of mathematical analysis behind it, but we don't need to go into all that. It's an abstract machine. It can be in one state at a time, and it's got a finite number of those states. It's deterministic or non-deterministic, and we're going to deal primarily with deterministic finite automata. And we'll be discussing that in this presentation. Deterministic finite automata, they operate under a set of rules. They have a finite set of states, and we represent that in C# as a list of state. Okay, or whatever you want to call the object. It doesn't have to be called state. They can take many different forms and have many different purposes. In math, they call that Q. That's the symbol they like to use to represent the possible states of the system. It's got a finite set of input symbols. This is sometimes referred to as a language. And for our purposes, they're messages. There's some kind of message that we're going to send in, some sort of data or information, and I like to just think of them as messages. They have a transition function, and in mathematics it's delta, and it's q and epsilon, or no, the sigma, q and sigma, and it returns a q, returns a state. Really what it is, it's a function called, we'll call it transition. It takes in a message and it returns a state. And the state could be the same state it was already in, or it might be a new state, depending on the message and the rules associated with the machine. They always have an initial or start state, and that initial or start state must be in that finite set of states, that list of states. And it has a set of accept states. Okay, and this is the rules that make up what a finite state automaton is, a deterministic finite automaton. Non-deterministic ones have slightly looser rules. They don't have to always return the same state for the same input given the same state and so forth. We won't go into that, and we won't go into the math about them. We will go into the programming, however, shortly. Software state machines, the traditional way, they're laid out in a table. And the table has rows and columns. The rows represent the current state that you're in. The columns represent some input symbol, in usually a number, so they can be looked up easily. And what you find at the cell addressed by the current state and some input state is a new state to go to. And it's something like this table here. These kinds of tables can get quite complicated. They are often used in compilers, and they're generated. These kinds of state tables are generated by compiler build tools like Yak or Bison, and Lex or Flex in the GNU world. These tools generate massive state machines of numerical values in tables that represent the transitions necessary to properly compile your code that your compiler is set up for. But those are generated tables. They're generated by a tool, and you don't manage the tables directly. State machines are used in a boatload of applications, almost everything you can think of. These are just a few representative examples across various things that tell you, we deal with state all the time. This is something we have to work with. Now, there are many situations where we represent these states in a lot of different ways. They're often in a process control system. A program might have a set of diagrams that you actually draw that let you link together different aspects of the process. And this is a type of state machine. And it's probably a deterministic finite automaton. In most cases, there's some exceptions to that. And then there is I say a better way. I think that it's a better way depending on circumstances. For instance, I wouldn't use an object-oriented style state machine for a compiler. Your compiler would probably be slow, and I think we want fast compilers, which is why we use development tools to create compilers and very efficient state machine systems in there. I don't know if you could even manually build such a complex state machine to compile a complex language using a state machine. But the state machine design pattern is useful for smaller state machines where you want to control things very, very carefully. And they can get fairly sophisticated, especially if you put a tool behind them, such as a design tool that does diagramming or something, which can be done. But the state machine design pattern, it encapsulates state in objects. It provides an abstraction. It allows actions to be formed in specific states. It creates the transitions necessary, and it maintains a consistent interface with appropriate design. It is testable. And that's important. It's important to abstract certain things out of it, and we'll go into that a little bit when we talk about the code. And here's a little bit of a UML diagram. Essentially, what you're saying is you've got some kind of an interface. We'll call this a state interface, and there are concrete states that implement that interface. That interface is important because you can mock out states and test the context and test things that are happening. A particular operation from the context calls an operation on a state, not knowing what state it really is. It shows in the diagram that it's calling it on state 1, but it's really calling an interface. It doesn't know that it's state 1. It just knows that it needs to call the operation. And it passes in this case, they're passing in this, which means they're passing in the context so that the state knows something about what's going on. And in my recommendation was the context should be an interface as well, if it contains data necessary for the state to operate properly. It should be abstracted in that way. And what it returns is, or it calls back to the context saying set state to a certain state, in this case state 2, and so forth. And this operation goes back and forth. The context only knows that it got its state set. It doesn't care what it is. It's going to call operation again on whatever that current state is. So with that, that's a general overview of how these state machines work. What we will do now is go into and take a look at the code.
Okay, so here we are in a new solution in Visual Studio called State Machine. And I'm using Visual Studio 2022. Here we go. Visual Studio 2022, and we're using .NET. Is it version 6 of .NET or C Sharp? I mean, I don't see it listed in here, but anyway, they've updated it a little bit. You don't have to put all that boilerplate around the main function. You just have an empty program file. You put code in it, and it just assumes that's the main function. So if that looks a little confusing, that's what it is now. It's just a main function right there. So the first thing we're going to do, we're going to take a look at this diagram right here. And what we want to do is, well, we're going to do this slightly different. We're going to create an interface for our context, and we're going to create an interface for our state. And we have to think about what that is. We want to call an operation on the state, and we want to call set state on the context. And we want to have a way to track that. So let's begin by, I don't know how I ended up opening that. Let's close that. So I'll come here and add a new item, and we want this to be an interface. They don't do that anymore. Oh, I was on the solution. Duh. Okay. We'll add a new item called an interface. There it is. And we want this to be iContext. So what does iContext have to do? iContext just has to have a function. We're going to say void, and we're going to call it set state, and it's going to take an Istate new state. Now we have to create the Istate function, and I don't have any tools installed, so I can't just refactor and do that. So we'll just go here, we'll go add new item interface, and we'll call this Istate. And the Istate interface has to have a function called, we'll make it void, what did we call it over here? Operation. And oops, operation, and it takes an iContext context. So that's our two interfaces that we need. Now we need to make up some states. Well, actually, the first thing we need to do is create an actual context. So let's go add a class, and we'll call this context, we'll call this the traffic light context. So the idea here is that we can have many different contexts for many different purposes, and they'll all use that same interface, iContext. And now we'll implement it. You're going to implement the interface. And we have this thing called the, we have an Istate called the current state. And then we'll have a list of Istate states. And so when we get back a new state, what do we have to do? We have to follow some rules, right? we want to do a little bit of error checking in this. Let me find the rules here, and we'll bring this over and review them real quickly. It's got a finite set of states. It's got a finite set of input symbols that are valid, some kind of messages. It's got a transition function, right? An initial state and a set of accept states. So we need to have some finite set of states that the context knows about, not that it knows about specifically, but we want to make sure that the new state that was passed in is one of the valid ones. So we have this list of states here, and let's do this. Let's go equals new list of state, so that we've got that valid list there. And we've got to have a way in our context, which we need on the I context as well. We need to have a function called add state, Istate state. So this will allow us to add states to the state machine, and then our set state function will set that initial state. We'll call that as well. So let's go back to our traffic light context. We've got our set state. We've got to implement this interface. We don't really need a constructor. Come on, I want to implement the interface. That kind of changed the way this interface works. So we've got add state, and we're going to go states dot add state. Oops. States dot add state. And set state is going to be if states dot contains new state current state equals new state. Yes, equals new state. Oops. Else, I have no idea why it's wanting to line them up there. That's a little weird. Else, in this case, we're just going to throw an argument exception that new state is invalid. Something along those lines. So that's not necessarily a good practice. You should have a better error recovery system here, but our purpose is to look at what a state machine is, and I don't want to get into all of the other abstract concepts that would clutter what we're doing. We're just examining what a state machine is. So in this case, we're just going to throw an exception if we get an invalid state. I don't think we will, because we're going to align things so that that won't happen. But we just want to be sure that we follow the rule that the new state it's going to is one of the valid states, one of the states that is acceptable to the system. Okay, so we've got our context. We've got the ability to set state. Now we need some sort of an action method on this, so we have to go back to our context, and what we're going to do is we're going to go here, we're going to go void operation, and we'll send in a message, Imessage message, and we're using interfaces, so we'll add that interface next. Add new item interface, and this will be Imessage. and a message is just going to have some sort of a string, I guess. Well, yeah, we'll have it. We'll have it contain a string. So let's go and add a couple of new messages. Add a class. We're going to say the message is we'll have a turn red message colon I message. We'll implement this interface. And what we will do is light change traffic light to red. And this is only so we can print out the message. The actual message is what will trigger the action, not the. It won't care about the internals. This is just so that we can print it out. Sorry about that dog barking. Hold on one second. Okay. Well, hopefully he won't do too much barking now. So we'll have a turn red message. We need a add a new class. Turn yellow message colon I message. Implement the interface. Turn light yellow. And we'll add a new message. Add class. Turn green message. Message. And if it will ever come up with the reason here, come on, there we go. Really? Implement the interface. Turn light red or green. Okay, so we have our messages. Now we need our 3 states. So let's add a class. We'll call this the red state colon Istate. Let's implement the interface operation iContext, and what we're going to do is say context dot set state. Now if we're in the red state, what do we want to do? Context dot set state this. No. So the red state needs to know something about what state it can go to. Let's think about what a traffic light does. It goes directly from red to green. It doesn't go to yellow. Okay? So set state needs to be able to set the state to the appropriate transition. So you know what? now that I think about this context, let's go back to our traffic light context. For our purposes, I'm not going to maintain this list, nor am I going to do this check. I'm just going to set the state to the new state. And we don't need this add state, so we can take that out of the interface, context interface. We don't need an add state. We're going to keep this simple. Okay. Let's go back to our turn, or our red state. Red state can only transition to green, so we're going to have I state green equals new green state. We haven't created the green state yet, but we're going to return, we're going to set green. Okay, and let's create the green state next. Add class green state Istate. Implement interface operation. Now the green state, if we're in the green state and we receive an operation from the context, we want to go from green to yellow to warn people that they're about to stop. So this needs a I state yellow equals new yellow state. And we're going to call context dot set state yellow. And now we'll create the yellow state. Add class yellow state. I state, oh, oh yes, I turned on the intelligence system in Visual Studio 2022, which learns what you're doing and pops up these great suggestions as to what to do, but I sometimes forget they're there. You can just hit your arrow key to the right and accept their suggestion if you like it. So the yellow state needs to have an I state red equals new red state. And what we want to do is call context dot set state red. Okay. Now we have those transitions, but you know what I'm going to do is I'm going to go up here to context, and I'm going to put something in our traffic light context. When we set, I'm going to go console.writeLine, console.write, transition, you know what, we're going to do it this way, $, and we're going to go current state dot oh, that's right, that's in the messages. So let's do this. Let's go back to Istate. See, I kind of just jumped in and didn't really think everything through. I had a pretty good idea in my mind, but what we want to do here is go string, iMessage. What did we do with iMessage? There it is. Oh, okay. We'll just do it that way. Let's go back to Istate. And it's a message. We'll call it, we'll just call it description. Get description. Okay. So I have to go back through our states here real quick. Those are the messages. Let's go to the yellow state. Let's implement that. Come on, implement it. Implement interface. And the description for this one is just going to be yellow. And we'll go to red state, and the description is going to be red, and the green state, where is it? Why am I not seeing it? There, it's all the way at the top. Green state. We'll just throw this in, and we'll say green, just so that we can get something to print out to show, be able to show what the thing is doing. Let me save everything. Okay. So we've got our transitions happening. Let's go back to our traffic light context, current state dot description. And then transition from yellow, let's put a space, to whatever. Transition from to on the state. All right. Now, our context. What have we not implemented? Operation. Oh. Yeah, yeah. So, when we get a message, and actually we got an iMessage, we've got different messages. Probably should go back and look at this context, comma, I, message, go back through our states, yellow state, operation, comma, I, message. We'll come back and use these messages in a bit, but we want to be able to pass them on for the moment. Yellow, red, comma, I, message, green, comma, I, message. Okay. So we're kind of a fixed set of states, but we're going to send in a message telling it to do something, and then we're going to see what we're going to do if we send in a wrong message that it can't do something, and what it's going to do on the system. And we'll come to that shortly. But for a moment, let's see if this basic construct works. We have our context, iContext. Yes, we have this operation where we send a message in. So our traffic light context, when this message comes in, we want to call the current state dot operation this, comma, message. And that should cause some transitions. So it doesn't matter what message it is at the moment. but we should take care of that in our states. So let's test it as it is, and we'll come back and see about sending in these different messages and maybe sending in wrong messages and see what kind of behavior we can create. So coming up here, what we want to do, we'll just write state machine. No, we'll call it traffic light. We'll go, so we'll go I context we'll go using state machine. Are these in a state machine? What are they? Yeah, namespace state machine. So we'll just back to program. We'll go I context ctx equals new traffic light context. We'll go ctx dot we'll go I state equals new. We'll go ctx dot add ctx dot set state new red state. And then what we'll do is we'll go ctx dot operation, and we'll just go ctx dot, no, we'll go I message equals new, and it doesn't matter about the message right at the moment. Operation message, and what we'll do is we'll walk it through its transitions. We're sending the same message several times and see what happens when we run it. Did it not run? What happened? Oh. I don't know how that happened. There we go. And Stack Overflow. Yellow state created a new red state. Okay. Well, this was a good lesson for you all to learn. We created a red state, and the red state went in and created a green state. The green state went in and created yellow state. Yellow state went in and created red state, and so forth. We created a circular thing. We can't do this. What we have to do here is just make this public. We have to set these from the outside. I very possibly should be embarrassed by that. That's what you get. That's the yellow state, red state. Yeah, we can't do this. Yeah, don't create dependencies inside anyway. It's a bad habit. I was just trying to be I was trying to be super simplistic. So Oh, I got to set that other one. Did I set that other one to public? So we can just set it. Um, we could, yeah, we'll just leave it like that for the moment. We go back to red state. Yep. Yellow state. Yep. They're all public. Okay, so what we'll do is we'll go into our program and we'll set those up. We have to go. We have to create the states anyway here. So we set the to new red state, but actually what we have to do is go create some states. So we'll go Istate red equals new red state, and we'll go red dot red dot oh, because it's not on the interface. Yellow state. So actually we have to do is go to the okay. I probably shouldn't do this sort of thing so late at night. Um, we're gonna do I state. We're gonna call not on the context. I state. We're gonna go I state next state set. And we're going to go to our states, green state, and we're going to implement this, and we're going to do not yellow. We're just going to go next state. There we go. Oh, next set. It's supposed to be next state. See, this is what happens. I'm getting tired. Next state. Let's go to the yellow state. Public. I state. Next state. Get set. Let's go to the red state. Public. I state. Next state. Get set. Green state. Public. I state. Next state. Program. Oh yeah, then we got to do this. We're going next. This is supposed to be next state. Next state. This is supposed to be next state. Okay. Now we can go back to our program and red dot next state equals new I state yellow equals new yellow state I state green equals new green state next state. For this is green goes to yellow goes to red. Set state not new, want it to be red. Message turn green. Operations. Okay, now let's run it. current state is null. Why is current state null? Did I not set it in the program? Context.setState to red. Context.setState red. Traffic light. Current state is null. Set. Oh, I'm calling this set state. Okay, because I'm calling, yeah. All right, again, a little sleepy. We're going to say if current state equals null, current state equals new state. Else, and I'll explain this in a second. So when we do the initial set state, I'm accessing it here before it's getting set, because I wanted to access it before it changed to print this out. I've got to set it the very first time. This should work now. Oops, just over here, and there it is. A transition from red to, okay, so let's put in one more thing here. Let's do console.writeLine. Actually, we can make this second one, darn it. Instead of console.write, we can make it console.writeLine and run it. Come back over here, and there we go. Traffic light, transition from red to green, transition from green to yellow, transition from yellow to red, transition from red to green, transition from green to yellow, transition from yellow to red. Now what we can do is make sure that the message is correct. So we can go into our individual states, the green state, and say that the Imessage here, and it's okay for states to know about specifics of messages. We could get some kind of a type from it, but the easiest thing to do here is if we're in the green state, if message dot message dot get type equals type of dot get type we'll make it does not equal. So if we're in the green state, the only thing that's valid is a yellow state, an insistence to go to yellow state. What we'll do is just return. We won't change states. We'll refuse. Actually, let's print out a message. Let's go console.writeLine invalid state message. Let's do this. Oops. $. And let's go message dot get type dot 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 full name. And return. So let's just copy this block and go to the red state and put this in here, and now this should actually fail. So red state, green state is the only thing that's valid, and in yellow state the red state is the only thing that's valid. Now it should give a fail message several times. So traffic light invalid state message every single time, because state message, turn green message. It's in red and it's not changing states, so it's always sending a red message. So now let's go back to program and send proper messages in. So we've got this green message, red message, and yellow message. We'll make this a red message, and we'll make this a turn yellow message. So we're in red. We started off, the initial state is red. It can't turn green message. It's in red. Red can turn green, right? As our initial state is set to red. Did I make a mistake? Yellow state. If message.getType does not equal type of red state, from yellow we go to red. The red state, if message.getType does not equal type of green state, oh, not green state. That's supposed to be turn green message. This is supposed to be turn yellow message. No, it's supposed to be turn red message. And this is supposed to be turn yellow message. Now it should at least work for one transition. Message. Ah, didn't do it. Okay. So we can send in a green message. And if we send that over and over again, we should get errors. So let's just put this in a few times. Should work the first time and then error out. Turn from red to green, and then we got invalid messages. So we have to go turn green message, then we have to go yellow message, then we have to go red message, then we have to go green message, yellow message, and red message. And now it should work completely. Transition from red to green, green to yellow, yellow to red, red to green, green to yellow, yellow to red. And that's how state machine works. So just as a quick overview, we have an I context, which allows us to set state and perform some operation based on a message, and it's got to be the correct message for the correct state or one of the valid messages. We have an iMessage, which just has a string in it. We have an Istate, which maintains a next state. It has an operation that takes a context and gets a message, and it can return a description. We have then individual states like the green state, which implement the operation and maintain a next state to go to. So these are the transition points, those accept states that work. And yeah, that's how it works. When a message comes in to the context to perform an operation with a message, the context calls the state. The state calls back into the context to set the current state to something else, which changes the behavior of this operation function, because now it's going to call a new state object. And as you can see, this can get quite sophisticated. So that's how it works in general. And yeah, thanks for watching. I appreciate it. If you liked the video, hit that like button. If you really liked it, hit that subscribe button, and I'll see you in the next video. Thanks for watching.